Crafting a scalable real-time analytics platform with AWS Lambda, Amazon Kinesis, DynamoDB, and API Gateway. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction to Serverless Microservices for Real-Time Analytics. In today's data-driven world, businesses must process and analyze data in real time to make informed decisions. Building a scalable, real-time analytics system can be complex and resource-intensive. However, leveraging AWS services such as Lambda, Amazon Kinesis, DynamoDB, and API Gateway can simplify the process while ensuring scalability, flexibility, and cost efficiency. This podcast will guide you through the steps to build a serverless microservices architecture for real-time analytics on AWS. Setting up the infrastructure, Kinesis data stream creation. The first step in building your real-time analytics system is to create a Kinesis data stream, which will serve as the primary data ingestion point. Amazon Kinesis allows you to collect, process, and analyze streaming data in real time. Navigate to Kinesis in the AWS Management Console, choose Create Data Stream. Configure the stream, name your stream, and set the number of shards based on the expected data throughput. Each shard can handle up to 1 megabyte per second of input and 2 megabytes per second of output. Create the stream. Once configured, click Create Data Stream. Your Kinesis data stream is now ready to ingest data in real time. Storing data with DynamoDB, table creation and configuration. DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. It is an ideal choice for storing the data ingested by your Kinesis stream. Create a DynamoDB table. Go to the DynamoDB console and choose Create Table. Define the table schema, specify the primary key and other attributes based on your data model. Consider optimizing query performance using a composite primary key, partition and sort keys. Configure read/write capacity. Based on your application's traffic patterns, choose between on-demand or provision capacity. On-demand capacity can be a flexible option for real-time analytics. Enable streams and TTL. Optionally, enable DynamoDB streams for change data capture and set up time to live, TTL, to manage data retention. Developing Lambda functions for data ingestion and processing. AWS Lambda functions are the backbone of your serverless architecture, handling data ingestion, processing, and analytics tasks. Ingestion Lambda function. Create a Lambda function that triggers on records added to the Kinesis data stream. This function will read, process, and store the data in DynamoDB. Code example: use AWS SDKs to interact with Kinesis and DynamoDB. Trigger: configure the function to be triggered by the Kinesis data stream. Error handling: implement retries and dead letter queues, DLQ, to manage failures. Processing and transformation: if your data requires further processing, such as aggregation, filtering, or transformation, you can chain additional Lambda functions to perform these tasks before storing the data. Creating Analytics Lambda function for data analysis. You'll need a Lambda function dedicated to analytics to derive insights from your data. Define the analytics logic. The function can run real-time queries on DynamoDB, aggregate data, or integrate with machine learning models. Optimizing performance. Use AWS X-Ray to trace and optimize the performance of your Lambda function. Ensure your function's memory and timeout settings are configured to handle the expected load. Configuring API Gateway for seamless integration. API Gateway allows you to expose your analytics services as a RESTful API, making it accessible to external clients or other AWS services. Create a new API. In the API Gateway console, choose Create API and select the REST API option. Define resources and methods. Set up resources and methods to handle requests for analytics data. For example, create a GET method that triggers your Analytics Lambda function. Integrate with Lambda. Use the Lambda proxy integration to connect the API gateway directly to your Lambda function. Enable caching and throttling. Configure API gateway caching to reduce latency and apply throttling to manage traffic spikes. Deploying the API and testing the microservices. Once everything is configured, it's time to deploy your API and test the microservices. Deploy the API. In the API Gateway console, create a new deployment stage, for example, prod, and deploy your API. Test the integration. Use tools like Postman or CQRL to send requests to your API and verify that the data flows from Kinesis through Lambda to DynamoDB and back through the API Gateway. Monitor and scale. Set up CloudWatch alarms to monitor the performance of your Lambda functions, Kinesis Stream, and DynamoDB. Adjust configurations as needed to ensure scalability and reliability. Conclusion. Building a scalable real-time analytics system using AWS Lambda, Amazon Kinesis, DynamoDB, and API Gateway provides a powerful and flexible solution for modern data-driven applications. This serverless architecture allows you to handle vast amounts of data with minimal operational overhead, enabling your business to respond swiftly to changing conditions in real time. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.